So University, today we are in chapter 8, part 5, and the title of our chapter is Power over the Ethernet. So without much ado, let's begin. First and foremost, let's take a look at the power over the Ethernet. Why are we using power over the Ethernet? You know, as campus network grows, more departments are being added, more faculties are created in a campus network. So when that happens, when the campus networks continuously and constantly keep growing, then there will be many devices that require electrical power that need to be powered in the campus. So when this keep happening, it becomes very difficult to power externally every device on the network. So when this become a problem, a challenge, or become impractical or unaffordable to run the electrical power on every place that we have a networking device on the campus, then we have to devise a technology to solve this problem as it emanates in the campus, as it comes in the campus. So what we do, this challenge, how to solve this challenge is to develop what we call the power over the Ethernet. So this challenge is solved with a technology known as the power over the Ethernet, PoE, power over the Ethernet. So when we find it difficult to run electrical power to every networking device on the campus network, we can solve this kind of challenge with the introduction of a technology called the power over the Ethernet. Now, this power over the Ethernet provides what we call the standardized technology that can be used to supply power over any existing cable, category 5 cable, or category 5E, or category 6 cabling that we studied in chapter 12 of this entire course. So this power over Ethernet is actually a standardized technology. It's actually a standardized technology. A standardized technology that helps to provide power over existing CAT cables. Okay, so now let's take a look at the benefit of this power over the Ethernet. Since we say it's a technology, a standardized technology that replaces the external cable, electrical cable, or power supply to networking devices. So let's take a look at this technology, the benefit it brings when comparing it with the external electrical supply system that we have. Now, number one benefit that comes from this is that we said, it is not very necessary to run external power to all networking devices once you have this standardized technology, PoE. So we can simply say with PoE, there is no need running any external power to all networking devices. So with PoE technology installed in the campus network, hence there will be no need running any external power to all networking devices. This technology is able to send power to all networking devices. That's number one benefit of having a PoE. The second benefit is that you can run power and data on the same cable. Traditionally, the cable for power, electrical power, is obviously different from the cable from the networking devices where we run data through. But with PoE standardized technology, with this standardized technology, we can run power and data, electrical power and computer data through this PoE standardized technology. We can run them through the same cable. So we can provide the power and the data over one cable. We don't have to have separate power cables and separate networking or separate data cables. So we can just use one with PoE. So you can see it's a huge benefit, it's a huge technology, and it's a huge benefit. We don't have to have multiple cabling, one running power in the campus and the other one running data in the campus. No, with this PoE technology, we can send both the data and both the electrical power through the same cable to our networking devices. That's the second benefit. Now, the third benefit is that this PoE, power over the Ethernet, can monitor power. And what we use in monitoring the power is called the Simple Network Management Protocol. The Simple Network Management Protocol. So with PoE, you can monitor your power. What power you have on the system, what power you are transmitting, what power you are sending to the PDs, we call them the PD, the power devices, through your PSE, the power source equipment. So what power are you using? So then you can do this with a simple software called the Simple Network Management Protocol. So we use what we call the SNMP, Simple Network Management Protocol, to monitor the power, to see what power we have on the system, how much power has been sent, okay? Power management. So we use this to do what we call the power management. We use the SNMP, Simple Network Management Protocol, to carry out what we call the power management. Monitor the power. How much power you have, how much you're sending, how much is left. That's the third benefit of PoE. Now let's take a look at the fourth benefit. Now you know that networking devices can be moved easily with this PoE technology because they're no longer wired externally. So the thing that is sending power to the networking devices are no longer like fixed in a position. So you can move them. So you can move all your networking devices to different locations easily without hinge. So these are not the fourth benefit of PoE. With PoE, only with PoE, okay? Without PoE, it's not easy to move all your networking devices easily. Then the fifth one, benefit of PoE, power over the Ethernet, the fifth benefit is that the power provided by PoE, as defined by the IEEE 802.3 AF, is as follows. 1. 50.4 watts per port. 50.4 watts of power. 50.4 watts of power, okay, per port to the Ethernet devices. So every port on the switch will have a wattage of 50.4. Every port on the switch will have a watt of 50.4. Then the entire system will have a voltage of what? 48 volts. The entire system will have 48 volts. Okay, the entire system will have what? The entire system will have what? 48 voltage. We have 48 voltage. Okay, so let's move on. The entire system will have 48 voltage. Now, PoE, still on PoE, power over the Ethernet. There are two pieces of networking hardware that are always explained whenever we talk about power over the Ethernet. The first one is called the power device. The power device, the one you send the electrical power to. And then the second one is called power source device, power source equipment. The one that is helping to send the power to the power device. Okay, so these are the two hardware whenever we're discussing power over the Ethernet. These are two hardware that we encounter when we're talking about power over the Ethernet. Now, there are three main functions provided by power source equipment. The first one is that every power source equipment, like a switch, every power source equipment has the ability or the capability of detecting a power device. A power device. It has the capability to detect a power device. capability of detecting a power device. That's the first thing, okay? Then another function of the power source equipment, PSE, is that it's able to supply power to PD. It's able to supply power to the powered device. It's able to supply power to the powered device. So this is another function of PSE, power source equipment. Okay, now the third function is the power supply monitoring. It's able to PSE is able to monitor the power. First, it's able to detect a PD, and it's able to supply power to the PD, and it's able to monitor the power that has been supplied to the PD. So these are three functions or advantages of PSE, power source equipment. Okay, now let's move on. The next one is there are two types of power source equipment. We have the endpoint power source equipment, and we have the midpoint power source equipment. Now, an example of an endpoint power source equipment is the source port itself in a switch. The source port in a particular switch is an example of an endpoint power source equipment. On the Ethernet switch, the source port on the Ethernet switch that connects via cable to a powered device is an example of an endpoint power source equipment. Then, in the case of midspan, or what we call the midpoint power source equipment, this one is used to provide power to a PD, that's to a powered device, when a powered Ethernet port is not available. When you don't have a powered Ethernet port, or like in the first case. In this case, you don't have a powered Ethernet port. When you don't have this, then you use what we call the midpoint power source equipment to help supply power through what we call ejector. Okay? Use the power ejector, and it uses what we call ejector to supply the power. This setup requires the use of a power ejector, and typically uses this pairing, 4 to 5 pair and 7 to 8. So the midpoint uses 4 to 5 pairing and 7 to 8 pairs in the network. And this does not support a 1000 base T connection. It doesn't support the 1000 base T. Okay? It does not support the 1000 base T in the system. Is that okay? Okay. Now let's move on. The power for power Ethernet, power over the Ethernet, the power to the PD, PD is a powered device. The power to the PD can be delivered in two ways. One way is using the pair 1 to 2 and 3 to 6. And another way is the pairs 4 to 5 and 7 to 8. So if you take a look at the first one, you see we're using, this is the switch power source equipment. This is the power source equipment. Okay, the switch power source equipment. And here you have the pairs. Okay, you see the pair here is 1 to 2. Okay, here we pair 1 to 2. And you see we're using the whole 48 volts. And also this one, 3 to 6. Pairing 3 to 6. And we are using the whole 48 volts. And this power device is connected. This pair is connected to a powered device, such as the access point. A good example of a powered device, we're going to talk about that later, is the access point or the IP phones, the IP Internet Protocol phones. They are a good example of powered device. They receive electrical power from the power source equipment. Okay, so this is for the A. The second one is the second pair, 4 to 5 pairs. You see here you have the vote here, and 7 to 8 pairing. So these are two examples that are available for PD. So the power in PD is delivered in these ways: either 1 to 2 or 3 to 4. Sorry, 1 to 2 or 3 to 6 pairing, or 4 to 5 and 7 to 8 pairs. This is how that power is delivered in a powered device in a network. Now let's talk about PD typically. The PD is the actual device, or a device on the network that is actually receiving power, that is getting power from the source. A good example is the wireless access point, which we've mentioned earlier. The wireless access point is a good example of a powered device. It's a good wireless access point is a good example of a powered device. Okay, another example of a powered device is the IP phones. The IP phones. Now there are 4 classes of powered devices. We have class 0, class 1, class 2, class 3. So therefore class 0, class 1, class 2, class 3, therefore. Now each class has its own voltage available that is supplied to it. Class 0 ranges from, the voltage supplied to it ranges from 0.44 watts to 12.95 watts. 0.44 watts to 12.95 watts. That's for class 0, the voltage that is available for class 0. Now, in the case of class 1, the voltage that is available, it ranges from 0.44 watts to 3.84 watts. 0.44 watt to 3.84 watts. This is for class 1. Remember, class 0 starts from the beginning of the voltage, or the beginning of the wattage, to the end of the wattage. Okay, that's class 0, meaning from the beginning to the end. But for class 1, it starts from that beginning, which is 0.44 watts to 3.84 watts. Class 2, we start from that 3.84 where class 1 stops. Class 2 starts from 3.84 to 6.49 watts. This is the power available for class 2. Now, class 3, for class 3, in the case of class 3, the wattage available, or the power available, starts from where the class 2's power ends. Class 2 power ends in 6.49. So class 3 power starts from there. 6.49 to 12.95, which is the highest wattage available for the different classes for this PD. Okay, so let's move on to the next one. Discovery process. PD devices, they are discovered. For example, like the powered device, they have to be discovered by the power source equipment before they can be supplied with the power. So the PD devices, they are discovered by the PSE, power source equipment. How does this happen? This takes place by a process, or in a way whereby the power source equipment will send a discovery signal on active and inactive Ethernet port. They will send discovery signals, okay, on both active and inactive channels, on both active and inactive Ethernet ports. So once these signals are discovered by the power devices, then the discovery process, called the resistive power discovery, is basically looking for these devices that will support the PoE, power over the Ethernet. Now, valid PDs will have a 25 kilo ohms resistors. 25. A valid PD we have a 25 kilo ohm resistor connected between the transmit and the receive pairs. So the resistance that is available connected between the transmit mode and the receive mode pairs is 25 kilo ohm resistors. Now, before we can deliver the full power, or before the full power is delivered to the PD, two low voltage discovery signals are sent out to verify that there is a compatibility of the PoE device that is being attached to the system. If there is no compatibility, then the voltage will not be sent out, will not be delivered. Now, the second of the two signals is slightly higher voltage than the first one, but neither is large enough to damage an incompatible device. Neither of the voltage is large enough to damage any incompatible device that is found on the network. So if the PSE, which is the power sourcing equipment, detects a compatible powered device, then the full 48 voltage or full 48 voltage or wattage is applied to all ports that have the compatible PDs connected to the system in the campus. Okay? But if it doesn't find a compatible PD, if the PSC does not find a compatible PD, then the voltage or the voltage 48 will not be sent. So remember, the compatibility are pairs of 1 and 2 in 3 and 6. Another compatible system is 4 to 5 and 7 and 8. So not until these pairs are found, this voltage cannot be delivered over the system. So the PD, the power source equipment, should be able to find a corresponding pair of a powered device that can take this available voltage of 48 volts. When this pair or this compatible powered devices are found, then the voltage will be transmitted or sent and be received by the power device. Be sent by the power source equipment and received by the power device. Now let's go to PoE plus. Nowadays we have what we call power over the Ethernet plus. The plus is like enhanced version, improved power over Ethernet. So a new versions of power over Ethernet called the PoE plus, based on the IEEE 802.380 standard. Remember, the ordinary PoE was IEEE 802.3AF. But the plus, the PoE plus, is based on IEEE 802.380 standard. So the PoE plus provide the following features. These features that are about to itemize. Number one features that the PoE plus has is that it's able to support both the 802.3AF, which is the ordinary PoE, that's the power over the Ethernet. Because once you see the AF, it means the power over the Ethernet, just the PoE. Once you see this one, it's just the PoE. This standard, okay, this IEEE standard 802.3AF. So, but this plus, one of the features of this PoE plus is that it's able to support the one that is not the plus, the standard. So it supports both the IEEE 802.3AF PoE and IEEE 802.380 PoE plus. So it supports the PoE plus and the PoE, ordinary PoE. So it's able to support both the IEEE 802.3AF PoE and IEEE 802.380 PoE plus PDs. All PDs that have these standards, this PoE, that's power over the Ethernet plus, is able to support both the PoE and PoE plus of these standards. That's what we say. Another feature, the second features, is that it's able to support the mid-span, what you call the mid-span, or what you call the midpoint. Mid-span PSE, power source equipment, for 10,000 base T. So you see, it goes a very long way. It can support the 10,000 base T for the power source equipment, the mid-span power source equipment. So it means it can go a long way. Okay. Then the third benefit or features of the PoE plus, that's the power over the Ethernet plus, is that it's able to support the minimum of 30 watts of power for the PDs. Minimum, at least able to support minimum wattage power for the PDs. Able to support 30 minimum wattage, that's the 30 watt minimum watt power for all power device, for all powered device. The fourth features is that it's able to support for a 10 giga base T. Yeah, because 10,000 is 10 gig. It's able to support the 10 G base T Ethernet. It's able to support the 10 G base T Ethernet. Then another feature of the PoE plus is that it's able to support is able to operate with Cat5 and even higher cabling like Cat5e. Cat5e, remember, is an enhanced Cat5. Is able to support Cat6. Cat means categories. Category 6, Category 5, Category 7, and so on and so forth. So Category 5e and so on and so forth. So it's able to support higher versions or higher modes of cabling in the system. Okay? Okay. So these are the features of PoE plus. Okay, now let's go to PoE problems. Some of the problems that ordinarily we're going to encounter. There are a limited or quite few numbers of problems with PoE as long as the device supports the IEEE 802.3 AF. You know, as long as anything that can support IEEE 802.3 AF comes with a level of challenges. Remember, the IEEE 802.3 AT is an improved version, the plus of the PoE. But the first one comes with a number of challenges. Okay? In cases where a vendor proprietary PoE equipment is being used, the PSEs and the PDs must be compatible. The challenge here is the compatibility between the powered devices and the power source equipment. This is the challenge. So there are some of these few issues and problems that comes with compatibility with PDs and PSEs. Then another problem is that could emanate is that the network administrator must be aware of how many PDs are connected to the PSEs. Now, the PDs are like your wireless access points, like your IP phones. How many of these IP phones, how many of these your wireless access points are connected to your PSE switch, your switches? How many of them are connected to your switches? Because when we talk about PSEs, we're referring to our switch, our routers and our switches, right? So how many of these wireless access point, or how many of these IP phones, okay, how many of these your IP phones do you have in your entire network? So as a network administrator, you should be aware of how many of these IP phones and access point, wireless access point are connected to your switch, are available on your network. So you should know, okay, in order to minimize the problem that could emanate or comes from this. Okay, you know how many are connected to your PSE, and that the total power requirements for the PDs do not exceed the PSE limits. Because if the total power of the PDs, power devices like your wireless access points, your IP phones, all the power that they need, if it exceeds the switch power, then there will be problems. There will be problems. So these are some problems we have in our network. So as a network administrator, we should be able to know what total number of power, what power is needed by the PDs, that's the wireless access points, your IP phones, all of them put together on your network, what total powers these things they need comparing to what you have from your source, which is your PSCs, your switch. What power your switch has that it can deliver to these PDs. So there must be a match. If there's a mismatch, then there will be a lot of engineering problems. There will be a lot of engineering problems. So to minimize the engineering problem is to design a system where there is a match between the PDs and the PSCs. The PDs, which are the access points, your IP phones, there must be a match of all these devices on your network when you compare them with your PSCs, which are like your switch, where the power is coming from. Okay, that's another problem that can come from the network. Then, example is a network could have 10 access points and 25 IP phones, all requiring power over Ethernet connection. Now, the total number of devices requiring power can exceed the power output for a PSE and possibly damaging the device. So if the total power that you have in your PDs are more than the power source equipment, then you will damage the power source equipment. Okay, because there's a mismatch already. So this is all we have for this segment 8 part 5, chapter 8 part 5. And remember, we've looked at the power over the Ethernet. What it means is a standardized technology that helps to deliver power even to a hard to reach location. It delivers power to very tough locations of our power devices on the campus network. And then we also talk about the power device. We say they are our wireless access point, our IP phones, and every other devices that we supply power to in our campus network. Then we also talk about the power source equipment like the switch that helps to bring the power to these devices. We talked about the endpoint power source equipment. We talked about two types of power source equipment. The endpoint, like your source port in your switch. And then we talked about mid-span or midpoint power source equipment, where you use an ejector, where you don't have a device that will directly deliver the power. Then we talked about the resistive power discovery. This has to do with the devices, the PSE and the PD discovery themselves first before the power is being delivered. And a resistive power is placed with a 25 kilo ohm resistor is placed between the source, the PSE and the PD. Okay, then we talked about the PoE plus, the power over Ethernet plus, which is an enhanced version of the power over the Ethernet. So with this, we come to the end of our today's class. Thank you for joining.